the deep learning models in correlation with AI applications, like how deep learning models are applied for different applications that adapts AI features. Okay, so everyone, I hope the participants are familiar with the AI concepts and technology. So I'm just going to walk through the technology, and my focus today would be more on the models, the deep learning models. Okay. So if you have any questions in between, you can just ask. So, like, I'm just beginning with the concept of AI in application development. So, all of us know that application development or the development of software packages involves different technologies, and we have different uh, application areas in which the software development takes place. And in this latest developments, AI, artificial intelligence prevails for more than 3 decades. Only recently, AI has got its more attention because of its allied disciplines like machine learning, language processing, especially deep learning and the reinforcement learning. So AI technology enables an application to be more smarter, with the ability to perform the task that traditionally requires human intelligence. So uh, this feature was enabled with the support of its evolved disciplines of machine learning algorithms, the natural processing systems, the deep learning models, and nowadays reinforcement learning models are prevailing. Like, after the introduction of deep learning models, we were able to focus more on the deeper information. It's possible to derive more information that was not possible earlier. So all these activities in terms of application development augments the performance ability of the technology industry, the tech industry. So that's the current thing. So what is behind all these concepts? We all know that AI represents human intelligence. So we humans perform complex tasks like vision, motor control, or language understanding very well because our brain consists of um, millions of neurons, which can also be considered as one of the inbuilt intelligent machine by natural by a natural intelligent machine. Okay, so this is a effort that was taken earlier to represent the human brain, and there were different models that were applied for artificial intelligence. Earlier, we had lots of machine learning algorithms that are used. Then comes the concept of neural networks, which we'll be discussing later. I'm not going in depth of the uh, designs and AI concepts and algorithms. I'm just going to focus more on the data concept. So when you take human brain, the brain is highly complex, non-linear, and a parallel computer. Now, what do you mean by parallelous? At the same time, you can do multitasking, like your vision sees, tongue, your mouth talks, you hear, you can move the different parts of your body. Like, it's called multitasking, and hence it's also referred as parallel computer. and it is composed of 10 to the power 11 neurons that is densely interconnected. No, so it has a group of neurons that was connected together, which we refer as neuron network. Okay, so however, this neurons shares a lot of data. Like it shares, or like we don't quantitatively measure the. We cannot measure the exact amount of data that was uh, communicated or shared by the neurons during a task. However, we can qualitatively measure the performance of the neurons with the behavior of the human. So, in order to represent this task, neurons are represented with the uh, physical computers like the chipsets. Uh, so when you compare neurons with silicon gate operation, which is 10 to the power minus 9 seconds, it's slower. However, the massive interconnection between the neurons, it is where till today, none of the scientists were able to exactly identify the network connections between the neurons. However, on based on assumptions, we assume the massive interconnection between the neurons make up for the comparatively slow rate of data transmission. Okay, so complex perceptual decisions arrived quickly, though we don't feel the difference. It because it's in terms of nanoseconds, right? So it's few hundred milliseconds or no, within few milliseconds or nanoseconds you come up with a decision, you make decision, you act, you react, etc. Okay, so there is a 100-step rule that is commonly used to narrate the functionality of neurons. Okay, so since individual neurons operate with very few milliseconds, calculations do not involve more than 100 serial steps. So what the scientists did was they split the performance, the process of neurons as 100 serial steps, not more than 100 serial steps. For any task that a neuron performs, they split the functionality into 100 serial steps, and the information sent from one neuron to other is very small. We can represent as bits, not even bytes, it's bits. So it's so fast, so quick, but the volume of data that was involved is higher. So since this data is available in the brain, the knowledge power within that is stored within the neuron, the neurons are able to perform its uh, task of executing the data or the information and coming up with a output or a decision. So, for example, say like right now, all of you may be viewing the screen. So, when you see in the screen, can anybody say how many colors are there in the currently displayed screen? Um, okay, so probably we can see five different colors, right? The background is white, the title and the other are saffron or orange. Then you have um, the word densely connected in blue, the other text are in black, and the 100-step rule is represented in green color. So totally there are 5 different colors. So how come you were able to understand that 5 different colors are there? So Vasanti Ravindran, good. Thanks for your reply. So we were able to analyze and understand the color. We were able to remember the name of the color, etc., based on the analysis, right? It took just few seconds, not even second, few milliseconds to understand how many colors are there, right? So that is what we have. We call it as the uh, processing, the speed of the neuron. Now, um, how is it possible for this analysis? Because the neurons are trained to understand the colors, remember the color name. That is what we called as the knowledge. So, in order to do this training, we need tons of data. Okay, so this information again in the brain we have a network, again a group of network that preserves the data, the information. Okay, so that is how the processes perform. The next important feature that should be remembered is the plasticity. Some of the neural structure of the brain is present at birth, right? Now we, as a child, when a child is born, it doesn't know much, right? It can just see, it can cry, it can sleep, it can move its legs and hands, it can open its eyes, it can listen. These are the few tasks a child can do. But as the child grows, it starts learning many things. Start recognizing the colors, it start recognizing the different types of sounds, the voices, the different people around it, etc. So as this growth comes, as the child grows, the neurons also grows. Okay, that is what we call it as the memory, right? So early stages of life is a time where the neurons are developed and it's trained to understand and to adapt to the to the environment. That is the new input. Once the input is received, the neurons are trained. It forms a bunch, a group. There will be different groups in the brain that is assigned to specific tasks. See, for example, for listening, there will be a group of neurons. For talking, there will be a group of neurons. For seeing, like vision, there will be different. For motor, action, for each and every activity, there will be a set of neurons. As the number of neurons grow, and this learning process continues until you die. But what happens is that after some time, if you are not using a specific set of neurons, the neurons will be dead. That is another key important feature that you have to be clear. So, this understanding is what happens in the brain. So, all these features are reflected in the technology, the application based on this concept is what the technical uh, areas like machine learning was evolved, and then comes the deep learning. Deep learning is where that enables the neuron training and the development and testing. Okay, so now what are the different when you come, so once you understand the concepts, we will now focus on the application development. So what are the different applications of AI? The primary area where artificial intelligence was imposed in different smart machines and software packages is the area of healthcare. So many applications are there. So many diagnostics tools are developed based on AI and machine learning algorithms. Nowadays, they also tend to apply deep learning models. So it's one of the primary area of applications of AI. And the next is the business for prediction of sales, marketing, etc., etc. Then comes the education, wherein you have smart classes and smart courses, online courses, etc. And we also have AI in autonomous vehicles. Like, um, I hope all of you have heard about Tesla. So it's one of the world's first autonomous and electrical vehicle. Okay, so that's in automobile sector. And when you come to social media, you can, without your visual awareness, you can sense the presence of AI in social media. Okay, for example, Google is one of the best tool platform wherein you can sense the presence of AI. If you just type the word, a word to search, it may be any word, you can see the related topics. There are recommendations automatically popping up. So that's one simple example of AI. Okay, and again, you can, the AI is applied in different activities like prediction of natural disasters, climate changes, whatnot. Okay, and also it's also applied in tourism development. So these are some of the major areas wherein applications using AI are developed. So so much of application, so much of technology that is used widely by so many people results in tons and tons of data. Okay, so I hope all of you are familiar with the term big data. You would have heard somewhere. You would have come across with different topics. Okay, in big data. So when you say big data, it's the fundamental uh, input, or we can say backbone of AI. Okay, only when you have large data sets, you can come up with intelligent systems. So AI is based on data, big data. So from this data, AI builds the knowledge base. Machine learning is used. Machine learning technology applies data for training the models, enable the models, the application models to learn about the data. And next comes the deep learning model, which not only trains the model but also uses the available data for testing and come out with more deeper information. So, for all these things, the backbone for any concept is the data, which are generated from different sources of applications. Okay, so appropriate data sets are required in order to uh, get the desired output. Okay, so what is this? How does it function? How does artificial intelligence applies big data for what? So this was uh, referred by Benke, and what he recommends is like there are three models: the AI model, which includes machine learning algorithms or expert systems, which uses the knowledge base or neural networks, which is widely used, and intelligent agents, pattern recognition. For all these models, There are different types of models that prevails in the sector right now. So for all these models, uh, AI requires data. Okay, so how do you get, or how does the applications acquire the data? Data acquisition is mainly based on the social media, the cloud, the broadband, the internet, okay, Internet of Things, and the communication media, the social media. So all these are the sources of data. You can acquire the data, or applications acquire the data from these sources, and the general characteristics that are applied for refining the data is like the variability, the variety, veracity, velocity, volume. All these features, characteristics are applied for the acquisition. So once you get the data ready, then the models are applied, and once the model is applied along with the data, then the process, modeling process like data mining, optimization, simulation, virtual reality, visualization, all these techniques are used for generating the desired output and visualizing the output. So how do you generate? Again, for generating the outputs, data clustering, hypothesis testing, inferences, regression, analysis, risks and uncertainty. All these statistical methods are used for the modeling process. Okay, so this is how the uh, AI technology works. So in this process, almost all the application process comes up with this concept. Okay, so in almost all the applications, there are two important processes apart from the modeling and the statistical analysis of the data. It is also important for prediction and optimization. Prediction is the primary output, the main output that is generated for any application. Okay, that is prediction. And if you want to refine your data, if you want to have more precise data, okay, so you go for with the optimization. So the top 10 predictions for AI, this is one of the examples, like is for AI in 2021. The predictions were like contactless words, robotics process automation, more explainable AI, federated learning, generative AI, next generation digital twin, deep enforcement learning, automated deployments, GPT-4, which is nothing but the generative pre-trained transformer, and the predictive and prescriptive analytical tools. So these are some of the predictions of for AI. Okay. So how was this prediction process is carried out? Like data sets, features and classes. So once the first thing is the you have to analyze the problem, understand the problem. So what is the output required, right? What is the prediction that needs to be made? Are you going to predict, or are you just going to process and generate? See, if you are just going to process and generate an output, you don't need AI technologies. AI technology is applied mainly to forecast or predict the outcome of any specific set. Okay, so in any prediction systems, okay, the first process is the data set. Acquire the data set that is relevant to the application. So, whatever may be the application, sets play a major role. So, once you acquire the data set, you have to pre process it. You have to remove the dirty data from the data set and classify the data based on the features that are required for prediction. Okay, so the classification of features and classes takes place in the pre-processing step. That is what we call it as extraction, data extraction. Okay, so once the data is ready, you have to build a model. Can be built like it can model can be either a machine learning algorithm or a deep learning model or a reinforcement model or a deep reinforcement model. So depending upon the problem, you first design the model, then you go on for the training set. The data set after extraction and pre-processing will be divided into three sets: the training set, validation test set, and the testing set. So the training set have the majority of the data, because the training set should have all kinds of permutation and combination of the data fields in the data set, so that the model is trained and it can predict whatever information is required. Okay, so the first set is used to train the model. So the training can be, as I said, it may be a machine learning algorithm or a deep learning model or a enforcement model or any other models. So we'll see what are the different models that can be applied. Uh, and once the model is trained, okay, once the model is ready, it can be validated. Validation is like tuning. Okay, so it's like fixing the errors if any and correcting it and making it looks 100% perfect. Okay, so once the model is ready, then comes the testing. So you test the model, and if you are getting the expected prediction, then it is considered to be complete. Okay, so after training and validation and test, your final model is derived, and based on the testing, it is refined, and finally, if there are any new cases coming in, then the model is applied to derive the prediction. Okay, so this is how the process flow of prediction in any application. So this is one of the example, that was this work was done by Lemon, and it's a free structure prediction of molecules, transition states, and solid state of a molecule. So this is one representation of AI application. Okay, this is another application that predicts when and where it's going to rain. Okay, so the different color patterns, the different patterns are used to indicate the different climatic levels. Okay, and this is another example uh, of predicting the financial uh, status or the condition of Amazon. Okay, so there are different types of statistical information, the um, diagrammatic, the tabular information, and the data sets, etc. So all these data are used for predicting the required information. Okay, so in this analysis, you can see that the prediction is made from 2018 till 2028. It's been made for 10 years. Okay, so it shows the e-commerce market, the advertising market, the the cloud market. So what would be the percentage of income, and what would be the total revenue, and what would be the net income, net profit. It's all prediction based, and the prediction outcome is represented in the result. So these are some of the statistical data. Okay, so this is how the AI applications are implemented. Now, the next task that is important in when you want to have more precise data is the optimization. Optimization is nothing but refining, the correcting the output. The uh, if you understand, though you get an output, if you find that it is not satisfiable, you can change the data set and reapply the process, repeat the process so that the data is more optimized to get the better data. So that is what we call it as optimization in AI. So if you have the input training data, you have the model, and then output, which is prediction, is calculated by the model. So once this sequence is fine, then it's okay. Now, after getting the output, you have to analyze the output, analyze the information that is generated as output. If there is any error or loss function, in order to evaluate the error or loss function is used, and this function optimizes the data. So there are optimization algorithms. One of the uh, commonly used optimization algorithm is the gradient descent algorithm. Okay, so this optimization algorithm is applied to get the refined model. So this model, again, once if it is executed with the uh, prescribed output input, you will get the relevant prediction. Okay, so this is what optimization process is done in AI. In normal machine learning algorithms, optimization is not, it's moderately used. However, when you go for the advanced models like deep learning and optimization, sorry, deep learning and reinforcement learning, optimization plays a major part in the prediction output process. Okay, so this is the pictorial representation of the process. You have the database, the collections, then you have the representation of the data, then you have the machine learning algorithm, then optimal composition. Okay. So there are different um, techniques that are used for optimizing your outcome or the output. Some of our the brown color zigzag output that you see first is called as the stochastic gradient descent algorithm. Okay, it's one of the widely used algorithm for optimization. Okay, then comes the batch gradient descent, then comes the mini batch gradient descent, and the green one is the momentum gradient descent. So all these are from the same group of algorithm called gradient descent algorithm. Okay, so this is a, a sequence of task or the process through which your application may go through while applying the optimization technique. Okay, the first one is the workload forecasting. It's again a prediction, so it's based on multiple workload drivers. Okay, so this next is the workload optimization. So this one connects forecast into the required working hours, optimizing the timing of different types of tasks. So each task differs from one another based on its time and the work that need to be work done. Okay. So next is the shift optimization. This creates shifts and matching them to the projected workload. So once you have uh, forecasted the required workload, okay, then you go for the shifts, creating shifts. So how many shifts are required for completing the tasks successfully, and how many employees are needed, what should be their skill sets, all these things are becomes the part of the optimization. So once the data is optimized more clearly, then it is used for more deeper predictions, right? And the workforce management, communicating the shifts. Once the shifts is ready, then it is communicated with the workforce manager, right? And the time and attendance and integration with payroll, again all these tasks are also handled successfully. So this is one simple example for optimization. Okay. Now, um, right, though the technology is developed so far, and we hear that AI is used for different tasks, like the machine learning is divided into deep learning and predictive analysis. And NLP, the natural language processing, is again classified, divided into classification, translation, and data extraction. And next comes the other AI systems like the expert systems, the uh, planning and optimization process, the robotics, the vision, the speech, all these areas, application in all these areas are getting more developed with AI slowly. However, this task prevails for more than a decade. So, this feature makes the CEOs of Indian companies, IT companies, specifically IT companies, do not believe in the technology. Only 10% of the Indian CEOs are confident. Others want to confirm on the reliability of their artificial intelligence applications. Okay, so this is the thing. In order to support AI applications and establish the concept with more or enable the users to gain confidence and make sure that it's more reliable is what need to be discussed. Okay, so I hope so far it's clear. Any questions? Okay, so now I'm um, just going to proceed with the neuron models, the neural network models and its architecture. So here comes the deep learning model. So already we know that AI is a representation of the brain intelligence. Okay, the functionality of the brain depends on the biological neurons that are present, and there are different types of neurons with different structures. Okay, so we there is no precise structure for them to use. So the connections of the network and the strength of individual synapses establish the function of the network. So though there may be many neurons in a group, the connections, it has to be connected appropriately to the correct neuron and the strength of individual synapses. So at the end of each um, analysis, or when you are going in for the establishing the function of a network, then it's the strength of the individual synapses that will support this. Okay, so the this is a basic structure, neuron structure. Okay, so the structure is adopted. So this is a biological neuron. So based on the structure, artificial neurons are designed, and a network, it's grouped as network, which we call it as neural networks, artificial neural networks. Okay. So what is an artificial neural network? It's nothing but it's a computational model of the human brain. So what is this actually is? It's a massively parallel distributed system made up of simple processing units called neurons. So that would be the simple definition of what a neural network may be. Okay, so it resembles the brain in two major, or two in two respective aspects. One is the synaptic connection strength among neurons, which are used to store and acquire knowledge. So in this diagram, can you see the synaptic terminals? All the neurons will have the synaptic terminals. One of the synaptic terminal will be connected to the axon, which is like a network cable. Okay, which is what one end is connected to the human brain or the uh, specific system. The other end will be connected to the synaptic term synaptic terminals of another uh, source. Okay, so this enables communicating on the sharing of information between the two neurons. So that is what a neuron is. Okay, so the same thing is represented here in the artificial network. So the main use of the neurons here is the specific knowledge. Okay, so this knowledge is acquired by the network from its environment through the learning process. So for this learning process, you are um, for this learning process you require the data sets. Okay, so this is the model of a single neuron. So this single neuron has four major components. One is the, apart from the input and the output, there are four main functions. One is the weight, second one is the bias, third one is the network model, then you have the function which is called as the actuation function, then the output. So input, there will be multiple inputs in a simple for a single neuron, there may be any number of input. However, for a, it will generate whatever may be the inputs. It will generate only one output. That is the specific feature of neurons. Okay, so a neuron can have multiple inputs, and it may generate only one output. So there are different properties of neurons that we are familiar with, like learning, adaptability, non-linearity, fault tolerance, etc. Okay, so it, however, it may also be characterized with issues like high dimensionality, noisy, imprecise or imperfect data, and a lack of clearly stated mathematical solution or algorithm. So those are some of the properties. Okay, so so this is the general structure of a artificial neural network. Okay, so there will be input layer and a output layer. In between the input and output, there will be another layer called hidden layer. Each and every neuron in the hidden layer is okay. So each and every neuron in the uh, network, okay, will have the multiple input, the weights assigned, the bias assigned. Then you have the neuron structure, wherein you have the model, the activation function, and the output generator. Okay, so here in the output is the prediction, the output generation is the prediction, and optimizing the data. Okay, in order to have more precise output is what is applied. So training the ANN means learning the weights of the neurons. So assigning weights to the neurons, adjusting the weights at different levels is what makes the learning process. Okay, so this is the general structure of the neuron, ANN. Okay. So when do you consider neural networks? Like you can use it for high dimensional data. If you want a discrete or a real value output, you have vector of values as output. And if you have noisy data, you can have target function, the uh, application areas wherein you can consider this model would be the image classification, financial prediction, etc., speech recognition. uh, so these are some of the areas. Now the key thing that needs to be considered here are the weights and biases and the activation function. So you randomly assign weights to each neuron. Okay, a neuron can have any number of inputs. So for each input connection that connects with the next neuron will be assigned a uh, value, that is a default value, that is called as the Okay, so these are the functions, right? You have the weights, you have the biases, and the activation function used for every model. So whenever you get an output above zero, it is called as the active neuron. When there are no outputs, or there are no, if the outputs are below zero, it is called as deactive activated neuron or dead neurons. Okay, so biases can be incorporated as another weight clamp to the fixed input of 1.0. Okay, so this bias makes the neuron more powerful, more stronger, right? So uh, there are many activations. So what is an activation function? It's also called as the squashing function, which limits the amplitude of the output. So it just tunes the output. It just verifies the output that is generated from the input set, tunes it, optimizes it, and then generate the output. So there are different types of activation functions. Commonly used are the linear and the primary simple models uses linear function, which is nothing but a equal to f of n, which is equal to n, the output. Okay, and next is a threshold function, which wherein if the input a, like the output will be 1 if n is greater than 0. The n is the input. So if it is greater than or equal to 0, then you get 1 as the output, and 0 if the n is less than 0. So this is a fundamental concept. So these are the widely used activation functions in a neural network model. Okay, first is the linear or the identity function, wherein you have the input and get the same as the output. Then you have the binary or the logistic uh, uh, function, sorry, the threshold function. Then you have the logistic, you have the tan h, the arctan. Then you have the rectified linear unit, ReLU. We call it as ReLU. ReLU is one of the commonly and widely used uh, activation function in deep learning models. Okay, then you have the PReLU, the parametric rectified linear unit. Then you have the exponential linear unit and the softmax. Softmax or the soft plus is again another activation function that is widely used. Okay, so all these functions are used, any one of the function depending upon the problem will be assigned and used for optimizing and generating the result. Okay, so when you come to the network connectivity, there are two types of major uh, connectivity. One is the feed forward networks, the second one is the recurrent network. Feed forward networks, like there would be the output layer, sorry, input layer, hidden layer, and the output layer. Each layer can have any number of neurons. The output layer again can, there may be any number of neurons, but more probably it will be one or two for a specific data set. Depending upon the number of features that are used, you get the similar number of outputs. Okay, so that is feed forward network, and it is just sequential. Feed forward networks are sequential, and it is considered as a and it's a computation of series of transformations. Okay, from input to the hidden unit, from the hidden unit to the output unit. There is no compare. This is a simple feed-forward network. The second type of connectivity is the recursive or the recurrent network, wherein there will be a redirected cycle in their connection graph. The output of one may become the input of the other. Okay, they can have a complicated architecture, and it's more, however, though the connectivity is complex, it's more uh, precise, it's more biologically realistic, because neurons are like this. Okay, so it's more powerful and complex network. So the different topologies, like when you have only one single layer feed forward network, there will be only one input layer and output layer. There will be no hidden layers. So this type of topology is uh, called a single layer feed forward network. And when you have the hidden layer, it is referred to as multi-layer feed-forward network. So you have one or more hidden layers. The input projects only from the previous layer onto a layer, so like from one layer to the next. Okay. So there will be any number of hidden layers in a model. It's not only one, but there will be only one input and one output layer. The middle layer, the hidden layer, may be any number. Okay, that is the feed forward network. Now, when you come to the recurrent network, again, it's like feedback. The output of one neuron may become the input of the next neuron, right? So the inputs are connected onto the outputs. It's more time sequential. Okay. And so the basic algorithm that is used for learning ANN is like, you have to, any algorithm that is designed, when this algorithm is the functional description of the neural network. Okay, so the first step is to initialize the weights, then you compute the um, approximate or the output value from the X by adjusting the weights in such a way that the output of ANN is consistent with the training labels. So with the training data set, you just apply a random. Initially, the first set of weights will have a random value assigned, and then it is changed accordingly during the training process. So once the output is generated, the output that is generated is passed through the activation function, which again passes, the output of the activation function is then passed through the error law or loss function in order to optimize the prediction. So this is one of the commonly used error function that is used, and this also enables to the output error or the loss function, loss prediction is also performed by the gradient descent, using the gradient descent algorithm. The gradient descent algorithm is mainly used to adjust the weights so that your output is more precise. Okay. Yeah. Okay. Um, so gradient descent is one of the algorithm that is widely used for optimizing your result. Okay, so the common scalar function that is used for adjusting the weight, calculating the weight is r by r, which is nothing but predicting the from it's just comparing the output that is generated with the required output. And another important thing in this prediction model, in the neural network model, is that always there will be a predicted or output is already known. You have to generate an output that matches the required output or the predicted output. That is how the model works. So this gradient descent rule adjusts the weight, the current weight, whether by finding the difference between the generated output and the predicted output. Okay, so based on the difference, that is also called as the error or the loss function. So using the loss function, it just measures the difference and adjusts the weight. So this is what we call it as the loss function and adjusting the weight. This is the gradient descent rule. And here the mu function is nothing but it's the learning rate. What is learning rate is like at what step the process is performed, how, what is the maximum value you can adjust on the weight. All these things are specified here. And next important task is the back propagation. Again, it's part of the training process. In a normal single layer feed forward network, it's just one process. Linear factor models have only one process. However, when you go for the multi-layer, when you want to have more precise results, more precise output, there is an algorithm called backpropagation algorithm, which iteratively process the training tuples and compare the network's prediction with the actual known target value. So this algorithm is the algorithm that checks whether the generated output is closer or almost the same as the predicted value. So what does it do? It just considers for each training cycle, which we call it as epoch, the weights are modified to minimize the mean squared error between the network's prediction and the actual target value. So this mean square error is what determines the weight, the adjusted weight. Okay, so modifications are made in the backward direction. That is, the output will be taken as the input to the next cycle, next epoch. This is what we call it as the back propagation. So this algorithm is widely used until the predicted value and the generated value is much closer. The error loss is minimal or zero. Okay, so this is how you apply the back propagation function. Okay, it's part of the gradient descent. Each For each epoch, for each back propagation, the gradient descent algorithm will be processed. Okay. Now, we quickly walk through the um, uh, more different architectures. I'm not going to deal with it. I'm just going to expose the different features and then move on to a small application using the CNN model. Okay, so there are different deep learning architectures, or we call it as models, that are widely used in real-time applications. In simple applications, this is one of the linear factor model. We can also call as logistic regression. Uh, model, like you don't have hidden layer, like you have the input and the output. Okay, it's processed. All the nodes, neurons are connected with all the outputs. Okay, so it's weight into the input, okay, plus the bias plus the noise. Noise is the distortion. Okay, so next is the autoencoders. Autoencoders are not uh, a model. However, autoencoders are like um, encrypting and decrypting the data. So from the input, each at each level of hidden layer, the data will be encoded, and it meets the central output process. After gradient descent optimization, it then decodes the data. Once the optimization is done and the output uh, prediction is perfect, it decodes the output. So this is what we call it as encoders, and there are different types of autoencoders that are used in different models, like the staked autoencoders and denoising on autoencoders, etc. Okay. Next comes the widely used network called as convolutional neural network. This is one of the uh, primary deep learning model that is used mainly for image processing, image recognition, or image uh, classification, or image processing for any type of uh, application that uses images. It This model is applied. We'll see in detail with an example. And next one is the deep generative model. This is a this model is similar to your linear model. However, it is it's similar to the recurrent model. However, uh, uh, the functionality is like any model can have the data sets, similar data set in different formats. So this deep generative models are applied for different uh, embedding processes. Okay, text embedding and embedding applications. Next comes the deep belief network and the deep Boltzmann machine network. Again, these models are mainly used for text classification and processing, right? And then comes the recurrent neural network. As we see early, recurrent neural networks are more complex networks. However, it generates more natural, precise output. Okay, so there are different types of RNN models, which we are not going to discuss here. And next is the multimodal or multitasking deep belief network. So you can use different types of data like videos, images, text. All type of data can be combined and processed for prediction. Okay. And next type of, this is another type of model called deep stacking network, DSN, which is like you can have different levels. You can have the input and the output layer, but you can also have in between, the hidden layers may also be distributed. There is no precise structure. You can have multi layers with different configurations. Okay, so these are some of the commonly used networks. And finally, I'm just going to discuss a a real time example, a small example using the CNN model. Okay, so consider you are training a model, you have designed a CNN model and trained the model to identify, recognize the image. So the image here that is considered as this bird, the bird image, and the prediction that is made is like where in the picture is the bird's beak. You have to normally identify the peak, precisely identify the peak of the and retrieve the peak of the bird. That is the uh, question. So some patterns are much smaller than the whole image. Now, this when you consider this, the challenge is like you don't need to identify what the bird is. You are asked to identify where in the picture the bird's beak is. So when you want to focus on the beak, the size of the pattern of the beak is much smaller than the pattern of the original image. So you have to extract the small pattern within the big image and then process the image that is extracted and confirm that it's a beak. Okay, so if you extract some part of the bird and say it's a beak, it cannot be accepted. See, for example, you can also take the toe of the bird and you can say that it looks like a beak, but it's not the beak, right? So the same way, the analysis should be more precise, the prediction should be more correct. So in order to perform this task, we have the CNN model. So you have to extract the particular part of the image and apply the function. This symbol indicates the pattern activation function that is suitable, and then you have the activation function is also referred as the beak detector. It is the activation function is the one that confirms that it's a beak or not. So from the small portion of the image that is extracted, we can use only fewer parameters. The bigger image will have bigger parameter, however the smaller image will be with few parameters. Okay, so this same pattern appears in different places and they can be compressed. So how do you train the model? What about uh, small detectors, and each detector must be move around. Now what does this mean is like consider this bird image. This bird is taller than the second bird, right? The second bird is more smaller, and it's again the beak is small. And when you take an image, though the image size is the same, but the image content differs, right? You cannot exactly say that the peak is located at the top, closer to the top left corner. You cannot say like that because for the first image, the peak appears on the top left. However, for the second image, the beak appears almost the center of the image, right? So the location may differ. The detectors cannot be exactly specified. So the location is here for the first image. So you have to go for the upper left beak detector. The activation function should be for detecting the upper left detector. However, for the second bird, the beak is in the center. You can go for the function that detects the middle beak, middle, the center part of the image, detects the center part of the image. Both these uh, but the functionality is the same, right? So each week, the general task that is assigned, the general prediction that is used in this application is to detect the peak of the bird. However, the features differ. This For this image, the the activation function would be upper left. However, for this, it's middle. So for the same application, you have to compress. You have to combine both the functions so that whatever may be the image that is given, it should be able to identify the feature. So this is what we call it as the feature extraction and classification. So this is a common convolutional network model wherein the image is divided into different frames, and you extract a single frame or filter the frame based on the detector, and then identify the or predict the outcome. Okay, so you can have any number of filters depending upon the image, and perform the task. So dividing the main frame into a smaller frames is what you call it as the convolution process. In the convolution network, you have the convolution process. Say, for example, if you have the 6 by 6 image, there are two filters wherein you can divide the image into 3 by 3. All the zeros are represented by -1, and other thing is in the +1. Okay, so you can create filters, and these are the network parameters to be used, okay, for learning. So each filter detects a small pattern which is 3 by 3. Okay, so the first filter is for the first. It's the dot product tree and stride 1. Okay, the second would be the -1, the stride 2. Okay, however, if the stride 1 and stride 2 is performed, okay, if it overlaps, then the outcome may be different. So it goes on like this. It moves like this, and finally the filter that combines this output, the location where the pattern matches this filter is what is extracted. Okay, all the +3. Okay, that is where the big lies in, right? Repeat this for each filter. You will get the next level of prediction. This is what we call it as feature mapping. Okay, and you can apply the colors channels if you want to. If it is a color image, to the filters, and then you get the you apply the convolution to get an approximate pattern. Okay, so this image pattern goes on, and you can have any number of frames filters generated, and the final filter that matches the value, only 9 inputs are connected and others are not fully connected. Okay, so there will be fewer parameters that need to be that need to be processed. Okay, so you have to filter the frames, the patterns that matches 3 and -1. So these are some of the shared values, and then reduce even few filters. So once you have reduced, then you go for the max pooling process. So this is what you call it as max pooling. Having the convolution, dividing the frames and then pooling it together and reducing the frames based on the parameter values or the shared weights. So once there are more common shared weights, then that filters are reduced. This process is repeated. You have the convolution max pooling. So this process can be repeated for any number of times. Okay. Once after going in for the max pooling, okay, okay, this is filtering. So once you have the pooling, you get the subsampling pixels, which are not the object. So you just reduce the size, the frame of the image. Okay, so that you have fewer parameters to characterize. So then you have the compress. You compress the network in two ways: by reducing the number of connections and shared weights on the edges. Max pooling further reduces the complexity. Okay, so you finally get 2 by 2 image. So the new image but smaller size. Okay, so now this image can go through the pooling and convolution process, and you get a new image, smaller image. Then you have the number of channels in the filters. So once the new image is generated, you go for the flattening and the final fully connected feed forward network. Flattening is just the taking the numbers row by row and put them into one long column. That is, you are reducing the matrix, the patterns, into a vector of values. The purpose is that we want the output we want this output as the input to the final stage of the ANN model. So you are converting the matrix into a vector, right? And then you have to apply this as the input to the fully connected feed forward network in order to obtain the result. So this is how a convolutional network works. So when you are developing an application, see for here, I'm just using Keras package in Python to develop the code. So the model, I just use the convolution 3D model with the input shape and the size. Okay, there are 25 3 by 3 filters. That is what is specified here. And the shape is like you have 28 by 28. That is 28 pixel by 20, the size of the image. Okay, one is to represent the color, one is for black and white, and three is for RGB. Okay, then comes the max pooling. So this is the code to that you have to add to implement max pooling, to filter, to apply the filters, to reduce or compress the size of the image. Okay, so you just filter the image. So from the input, it's a 28 by 28 pixel size. You design the model, you apply the convolution, divide the input image as 25 filters of size 3 by 3. So you have 25 into 26 by 26. Then you apply the max pooling, reduce the size further as 2 by 2 matrix. So it is 25 by 13 into 13. Okay, then again you apply the convolution, which is to divide the 13 by 13 pixel, 25 images of 13 by 13 into 50 frames or 50 filters of size 3 by 3. So you get 50 into 11 by 11. Okay. Then again, you reduce it to a 2 by 2 matrix, for which you get 50 into 5 by 5. Okay. So you can repeat this process. So how many parameters for each filters? There are 9 parameters, because 3 by 3, that is 9. Okay. So how many filters here? It's 225, 25 into 9. So based on this outcome, you flatten the matrix. You apply the flatten function for with the input 1250. Okay. So this 1250 inputs are applied as a input to the feed forward network. That this is how you apply the coding. Okay. You use the dense function to make it fully connected. Then you apply the ReLU activation function to uh, predict, to make the prediction, to generate the predictive output. Then you apply the softmax function again to optimize the output. Okay. Next, this is how you come out with the prediction of the outcome. Okay. So this is one simple example of how you do implement a CNN model for the image recognition process. Okay. This is another structure for text classification. For this also, you can use CNN model. For example, if the message is "I love my new phone," okay. So how is the text recognized? Okay. So this is one representation, one model. Okay. And again, this is a spectrogram of speech. So you can analyze by dividing the spectrogram image into frame by frame. Each frame have its own input and output. Okay. So this is how you perform the task. So this is some of the examples of how AI based applications, especially the deep learning models, are applied for various tasks. Okay. uh, eh, Thank you. That's it for I talk. Any questions can ask? Sorry, I can't hear you.
Participants, if you have any queries, you can ask now.
Good afternoon, ma'am.
Yes. Yeah. Good afternoon.
It's underfitting and overfitting.
Yeah. Like when you go for the prediction, like the model, if it's the underfitting and the overfitting is usually measured when you go for when you apply the loss functions, like the cost function of measuring the prediction. It's part of the optimization. Okay. So what is that you want to know about uh, the under and overfitting? in model because it changes with different models. So I'm just wondering where you would like to apply this function. It's mainly related to the cost function, like whether the data set matches belongs to the specific group or a specific uh, hidden node or the neuron set within the network. So if it exceeds or if it is below the requirement, below the predicted value, then you say that it's underfit. It's above the prediction value, it's called overfit. Okay. So what type of it depends on what type of data sets that is used and what type of model you apply and what type of prediction you are supposed to make. Okay.
Any other queries?
Is there
Esma.
any relation between features and these overfitting?
uh, it is
Feature
it
increases the
yes, go ahead.
ma'am, if we increase the feature, it will come underfitting or overfitting.
uh, Sorry, I can't hear your question clearly. Can you just repeat it again?
Just I'm using 20 features. Uh,
Okay.
Suppose if I require 25 features, okay, ma'am,
Okay.
there is number of features are increased. If we increase the number of features, we can reduce the chances. Okay, ma'am.
uh,
Multi
See, the number of samples and the number of feature is not directly related. We don't measure the number of data sets, or we don't use the data set size to measure the to estimate whether it's overfit or underfit. It's the content, right? So
Okay.
though there are whether it is 5 or 10 or 15 or 20 or 25 features, okay, the same
Okay.
data set can be applied. If you are earlier, if you have 20, now you have 25. Okay, the
Yes,
features
ma'am.
doesn't matter. It's about the content and the characteristics of the feature that determines. Okay, and it just because this estimation is mainly performed when you go for it also depends on how quick the prediction is made, like if it belongs to the feature, that is what is more important. Okay.
Okay.
Yeah.
Okay, thank you.
Thank you.
Ma'am, there is a question in a chat box.
Yeah.
Angirkani is asking whether we can apply hybrid concept in NN to predict the to increase the accuracy.
Yeah, you can apply the you can apply hybrid. See, for example, we have the CNN, the convolutional, the max pooling, the flattening process, along with the linear model, the feed forward multi-layer feed forward network. Or you can apply the auto encoders, you can apply the Monte Carlo method. So it's hybrid. Depending, the key thing is the application and what type of prediction you are supposed to perform. That is more important. Okay, I think there is another question. So how do you improve hybrid activation function? Like, see, you cannot say a hybrid activation function. There is no improvement of high. See, a mathematical function is a function. Okay, each function has its own features and each function has its own functionality. It's up to the designers or the developers to apply the appropriate function. Okay, so there are two levels of functions that are applied. First one is the for the prediction, to measure the output. Okay, to calculate the error loss. That is the first function. The second thing is the softmax function again, the activation function that is applied to optimize the result, right? So there is no concept of hybrid activation function. You can use multiple activation function, or you can also add another function so that you can refine your input. For in case of reinforcement learning model, deep in reinforcement models may require more than one activation function. You can use the number of functions, you can increase the number of functions, but you cannot combine the functions. When you combine the functions, it becomes more it becomes a new function. So yeah, if we use mask or CNN for segmentation process, uh, do you mean can you use recurrent CNN for segmentation process? Is that the question, Archana?
Any
uh,
questions?
yeah, I think there is a question for pattern recognition. Yeah, you can use RCNN would be, it depends on the uh, precision that is required for pattern recognition. You can use it. Yeah. Okay. Thank you.
Thank you, ma'am. You have given a skillful talk